Welcome to video lecture, a course material on CE 8020 maintenance, repair and rehabilitation of structures, presented by R. Rajiv Gandhi, Assistant Professor, Department of Civil Engineering, Rohini College of Engineering Technology, Palkulam. Good morning to all. This is Unit 2, Strength and Durability of Concrete. Let me discuss about cracking of concrete. Cracking will occur whenever the tensile strain to which concrete is subjected exceeds the tensile strain capacity of the concrete. The tensile strain capacity of concrete varies with age and with the rate of application of strain. Cracks are developed when the stresses are exceed its cracking strength in the structure. These are likely to spoil the internal finish of building due to the penetration of moisture and thus increase the cost of maintenance. Cracks due to different causes have varying characteristics. It is by only careful observation of the characteristics that one can diagnose the causes of cracking and adopt the remedial treatment. The next one, types of cracks. The major two types. The first one, structural cracks. Second one, non-structural cracks. The structural cracks are those which result from incorrect design, faulty construction or overloading, and these may endanger the safety of the building and their inmates. Then second one, non-structural cracks. Non-structural cracks occur mostly due to internally induced stresses in building materials. These cracks normally due to endanger the safely but may look unsightly, create an impression of faulty work or given a feeling of instability. The next one, classification of cracks. The classification of cracks: thin cracks, medium cracks, wide cracks, settlement cracks, shrinkage of concrete, plastic shrinkage, drying shrinkage. The thin cracks less than 1 mm in width, medium cracks 1 to 2 mm in width, wide cracks more than 2 mm in width. The occurrence of closely speedifying cracks at the surface of a material is called crazing. Thin cracks are even closely spaced or less damaging to the structure compared to a fewer number of wide cracks. The next one, settlement cracks. Plastic concrete when vibrated or otherwise settles. If the concrete is free to settle uniformly, then there is no crack. If there is any obstruction to uniform settlement by a way of reinforcement or larger piece of aggregate, then it creates some voids or cracks. This is called settlement cracks. This generally happen in a deep beam. The next one, shrinkage of concrete. Shrinkage of concrete is one of the important factors contributing to lack of durability of concrete. Shrinkage is mainly responsible for causing cracks of large magnitude or minor microcracks. The aspects of cracking is concrete is very complex, involving many factors such as magnitude of shrinkage. Cracks can be avoided only if the stress induced by shrinkage strain after relaxation by creep it at all time less than the tensile strength of concrete. When we discuss about the shrinkage of concrete, the following aspects of shrinkage are required to be considered. The next one, plastic shrinkage. Water from fresh concrete can be lost by evaporation of absorption by subgrade formwork and in hydration process. When the loss of water from surface of concrete is faster than the migration of water from interior to the surface dries up. This creates moisture gradient which result in surface cracking while concrete is still in plastic condition. In such a situation, the following measures could be taken to reduce or eliminate plastic shrinkage cracks. Moisten the subgrade and formwork. erect temporary wide breaker to reduce wind velocity over concrete, erect temporary roof to protect green concrete from hot sun, reduce the time between placing and finishing if there is delay, cover the concrete with a polyethylene sheet, minimize evaporation by covering concrete with a burlap fog spray and curing components. Then finally last one, drying shrinkage. Drying shrinkage is concrete is an inherent property of concrete. The shrinkage is one of the fundamental reason for initial induction of micro cracks in concrete. The mechanism involved is too complex. Generally, the pattern of shrinkage is a function of cement content, water cement and water cement ratio. In practical terms, at a constant water cement ratio, shrinkage increase with an increase in cement content. But a given workability, which approximately means a constant water content, shrinkage is unaffected by the increases in cement content, or shrinkage even decreases because of lower water cement ratio. At lower water cement ratio, concrete is stronger to resist shrinkage, but it should not forgotten that stronger concrete creeps less than is less stress relaxation of and therefore more micro cracks. It is maintained earlier than 50% of shrinkages will have taken place in about 35 days, or considerable amount of shrinkage will have taken place near the surface even earlier. At such an early age, the concrete will not have attained good strength to resist shrinkage stress, and therefore the concrete is much more vulnerable to cracking in spite of stresses relaxation by high creep at low strength. Thank you.